So I had the privilege this morning of being introduced in the first talk by Sam Newman when he said, what can be the worst type of monolith that you can have? And that's actually a distributed one, which is what I'm going to be talking about. And he also defined it as the distributed monolith because life is not hard enough. So if you are interested in learning what does it take in the real world to actually create a distributed monolith, you've come to the right talk. So first things first, I'm going to introduce you first to the BBC, okay, and what we do in the personalization space, so you get an idea of the context of the talk. Then next, I'm going to introduce the problem space that I work in, which is data analytics processing. After that, we'll dive into where we created the first version of this data analytics processing and the data platform at the BBC and how it ended up being a distributed monolith. So we'd go through the reasons why we called it a distributed monolith and what we learned. And then, well, we actually had the opportunity to move away from this monolith. So I'm going to walk you from the very beginning through the steps that we went into designing the next version of it. And then last, I will highlight and share with you a few of the questions that we're asking ourselves, looking beyond what we have right now as a data platform. So first things first, I work at the BBC. And we're known for doing a bit of news on radio. But we have a breadth of services available for audiences. Some of these services are iPlayer. It's a very popular TV catch-up service in the UK. We also have BBC Sounds, which is a live streaming radio, but also a podcasting service. We have CBeebies, which is a channel and a website dedicated for children and kids. And we even help them with tools to revise for exams. And we also have a very popular weather service because we're in the UK, so we love to talk about the weather. But then within the BBC, I work in the personalization space. Okay, I work in the big data team. And what we do is we ingest data from various sources inside the BBC and also external. And we process that data and store it internally in what we call a data platform. We have about 50 million users registered with accounts in the BBC. And when those users register, what they unlock is a set of personalized features. So they will get access to personalized content via recommendations. You also get notified, for example, if David Attenborough is on the radio when I usually watch him on TV, and that sort of thing. But you are probably wondering, why would the BBC go into the data space as a public service? So there's different reasons why we would do this. The first of them is, well, it's 2020. People on the internet expect things to be tailored to them. We all have these expectations that the services are going to know something about us. But in order for them to give us content that we might like, we need to give them and trust them with our data. Okay, so the aim of the BBC is not to track people, okay, is to give them a better experience with their services, because in the UK, people pay a license fee for us, and that's one of the main ways that we found ourselves. So we want them to give value for that service that they're paying for. Also, we have a privacy promise, which is public. You can visit it on that link. And this privacy promise is made of two parts. The first one is, what does the user, what does the audience member get when they trust the BBC with their personal data? So if, as an audience member, I register for an account with the BBC, I'm going to be asked for quite personal information, including what is your email, what is your date of birth, or what is your postcode. And by me trusting the BBC with that data, what I expect to get back is a set of personalized features. I said earlier, content recommendations, but also if a general election happens, we try to tailor data, we try to tailor the experience to what the person's postcode, or at least the postcode they have given us, is. So for example, we would give them the local information to the constituency they've voted with, and that is meant to help them get better informed and then cast their votes. We're not trying to change their opinion. We're just trying to give them access to information so they can educate themselves. But then, on the other hand, what does the BBC get by getting all that data from the users? Well, I said earlier, we're a public service. So we're meant to have useful services for the breadth of the UK nations and regions, so all the different audience profiles that we have within there. So by being able to measure what the reach of our services is, we're meant to be able to create a better BBC for everyone. And these are the two parts of the privacy promise. But then within personalization, we talk about what is kind of the gradient of personalization, and there's an acceptable side of it, which is what we call, well, the side of the Doctor Who. And this is where the BBC tries to be, so for the users to get a positive experience about their usage of BBC. And then on the other side is more the Dalek. So this is when you're using services online where you feel that they know more about you than what you've given them, or that they're trying to hook you to use their services and just kind of spend endless time in them. And this is not where we aim to be. So secondly, I'm going to introduce you to what is data analytics, because I learned that not everyone understands kind of the complexity of the problem space that we work with. So this is end-to-end what a data analytics pipeline looks like. On the left-hand side, we have the users, which is the audience members. This is people like you and me going on BBC News website, using the mobile apps, and just kind of tracking, reading content. And when people do this, well, there's an analytics web server that collects data on the back of that. This data is then stored as activity logs, and then they are ingested and processed. And at the end, they're stored internally in what we call the data platform. And then we have internal users at the BBC. These internal users are people such as data scientists and data analysts. And what they're doing is they run reports, they're looking into the data, they're measuring the performance of different products, or they could be seeing what the performance of a given episode of Killing Eve was, for example. And the team that I work in is mainly in the processing and storage and access layer, okay? And this is what we'll be talking about next. If we dive one step further into that processing and that storage and access, these are the different phases that usually the data goes through when you're ingesting it. You get the data, then you do some validation, because usually your collection happens in a third-party service. You normally don't trust all that data that you're receiving in. Then we do some transformations with that data. We call that process enrichment. And by enriching, I mean, for example, if I'm watching an episode of a TV program, the enriching process will take the identifier of that TV program and append some metadata of the TV show. So at the end of it, we can have the title, the description, when it was aired, the duration of the show, things like that. After that, we format the data, and this is to put it in a format that can be easily queryable. Okay, in the big data space, we tend to use columnar data formats very frequently. And that data is put into a data lake, which is usually just big scalable cloud storage, and then a data warehouse where only a subset of the data is usually kept, and is where mainly the reporting happens. So the layer that our users use to access the data is usually via the data warehouse, mostly, and the data lake. And this happens as a SQL interface. So this is a bit of a different area than when we speak about microservices, where usually it's HTTP interfaces, okay, and API contracts. For us, our contract with our users is actually SQL. We put the data in a format that we think is going to make sense, but it's a lot more flexible, because SQL allows them endless possibilities. So it's quite a challenge. So now the distributed monolith, how did we came about being in this space and making our lives so much more interesting? Well, this is the first version at a high level. This is what we came about. So we identified 3 separate services. Okay, one of them was downloading the logs from the third party. Then we had MapReduce. This is distributed computing at scale, processing all that data. And we did it at scale because, well, at that point, the third-party provider was providing us the log once a day. So we had to download all the data in one go, and then process the next step in one go, and then format it. So it was a big batch all over the place. And this is what the actual architecture diagram looked like. I've put a purple kind of dotted line around it because the 3 separate services were actually orchestrated by a service called Amazon Data Pipelines. So the reason why we picked this technology was because we thought, oh, we have these 3 separate phases that are very closely linked with each other. And orchestration is meant to help you recover from intermediate failures along the different steps. And we had, well, choices, Python applications, then we use Apache Spark as a framework, which is really, really powerful, and another Python application to load the data in bulk. So what we're going to be looking at now are the failures that we went through. But as I said, we're working in the kind of the intersection of microservices and big data. And this is quite an interesting area because big data, you would never think it's microservices. Some of the services that I've just showed you in the previous slide are quite hefty, such as distributed computing. So let's take that we're gonna look at the rest of the talk as being influenced by microservices principles. And to give you an idea of the scale of what I'm showing you, it's billions of messages per day. So that's the scale that we work with. And the data that we store is on the petabyte scale. And this is not the only ingestion pipeline that we have in our team. We have a few dozen of this. But the one that I'm showing you today is actually the highest scale one that we have. Okay, the rest of them, we solve them in different ways because when you're only working with millions of records, it's actually a different way of solving the same problem. What did we learn? Well, I'm going to show you 7 lessons that we learned from this. First one, you probably spotted it, batch. It just smells bad. But this is very typical of working with big data, working with kind of batch systems overnight that they do their work and then reports are available the next morning. The third party provides us the data every day as a batch. And the kind of assumption or mistake that we made was that we then assumed that all the other steps in our pipeline had to be batch. So you probably guessed it. When things failed, they failed in batch as well. And imagine digging through billions of records. When things fail, it's just like going into a haystack and trying to pinpoint, because each one of these billions of records on top of it had hundreds of different columns. So yeah, it just takes me back in time. I don't want to go back there. The last one, the second was the second phase, which was the distributed computing. This is where we were meant to be doing validation of the input data and also doing testing, because when you're working with distributed computing, you have to understand not only the framework, but how the platform then splits up the different jobs and how the data gets shuffled between the different nodes doing that computing. Well, we weren't validating the data enough. So when things failed, debugging that in a distributed fashion became really hard. And also because we had not really invested in enough testing at the kind of upper layer of the testing pyramid, which is the end-to-end. We really didn't have a reliable way of putting data in through one end and then kind of validating at the other end. We had a lot of unit tests that kind of check the different functions, but not so much at the top. A third lesson, tight coupling. I hinted at this earlier. We chose this orchestration service in Amazon because we thought it was going to help us recover from the intermediate steps. But the way we had designed our services and kind of the layers that the data went through, in reality, they were too tightly coupled. So it was really hard when one of the phases failed to replay the data from that point onwards. So we were then having to clean up the intermediate mess and then starting over. Okay? That made our lives really hard. The other lesson about tight coupling was about the data itself. So the data that was being collected was given field names, which sometimes they didn't really make much sense for our users downstream. And there was a coupling between the data model that the web server, the analytics web server, was using with the data model that we were exposing internally. And our users said, this actually doesn't really work for us. Okay, a lot of these fields, they have names, I don't know what they are. And then if anything changed upstream, you have guessed it. It just kind of broke everything underneath, especially the data warehouse, because it had static data types. Okay, so you have to do all that cleansing prior to things getting into it. Lesson number 4 is, well, this is about alerting. So when you're working with microservices, you have to have enough metrics, enough monitoring so that you know what the health of them is. We thought that by using the orchestration, it would help us know when things had failed, where they had happened. But in reality, when we operated things, this wasn't the case. When things failed, we had to dive into every one of the phases, and we spent a lot of time digging into that. So we really didn't have enough alerts. But then we said, oh, this is easy to fix. We can just add more alerts. And then we ended up on the other place, which is when your inbox and your Slack and everything is just clogged with alerts. And everyone in the team is just constantly looking at it, and it's just, you're being interrupted all the time, and this is not where you want to be either. Lesson number 5 is about understanding your traffic patterns. So you usually make assumptions when you design an architecture and a service, and you break down microservices about what your expectations of data flow are going to be. And we have something quite particular at the BBC, which we call Big News Days. And what these are is, well, we're a global media organization. We had some predictable news days, which they can be big concerts and festivals, such as Glastonbury. People will go online en masse to watch them. They are general elections. They're also highly anticipated. They can also be tennis tournaments, such as Wimbledon, or even royal weddings. But then, on the other side, we have unpredictable news events, and these are usually atrocities, catastrophes, and tragedies. And those happen all of a sudden, and they really drive traffic to our websites, our applications, and the streaming platforms that we have. So to give you an example, I put a screenshot there of the weather, because a couple of years ago, about this time of the year, we had in the UK what we call the beast from the east. And this was just kind of an air mass that went over the UK. And I even have pictures of it. There was just snow and ice all over London and the rest of the country, and things just stopped. And what that meant for our data platform is that we saw a 50% uptake in traffic. When you're working in the billions, 50% is quite a lot. Okay, so changing for that, adapting to that very quickly, your microservices, they need to be able to scale. And within your architecture, there will be different requirements of scaling alongside it. And that's not where our data platform was back then. So it was very, very hard to scale. Also, we learned that over time, our data was only increasing. Okay, looking 6 months back, it just keeps going up and up and up. So we've also had to kind of change our projections going forward to cater for more and more data. And then lastly, because, well, we're a public service, the things that we build, they have to have some cost analysis behind them. So it's kind of, I've said almost the opposite, and the same thing just now, as in, well, we have increasing data volumes, but we have to keep the cost down. That's quite a challenge. And now the last of the lesson, well, it was actually talking to our users. So at the other end, the very far end, we have internal users, which initially we didn't really listen to them very much. But then we began having what we call coffee and data. So these are monthly meetings with our users. We give them a bit of coffee, some biscuits, and then we hope that they have little chats amongst them and with us. And what they told us in these chats, in the months that we've been talking to them, it's been, I think, more than a year now. First of all was that the data was in a shape that it was very hard to use. And secondly, that when they were using the SQL interface to query the data, they were having to do the same calculations over and over. And some of these calculations could be quite expensive, so the queries could take a long time. So we thought maybe we can work together in the future and do some of these calculations for them. So when they access the data, it's in a more friendly shape for them. So now, well, we've learned what the distributed monolith was. How did we come about to move away from it? The BBC as a whole decided to change analytics provider. And this is when I saw the sky open, and I thought, oh, wow, this is the opportunity, the big opportunity we've been looking for. We can now think about how we're going to tackle this. So we're going to have to we were going to have in our team to integrate with a new provider, but also the shape of the data we're going to be ingesting was going to be slightly different. So there was a big exercise across the BBC about what the future of the data and how it was modeled was going to be. I'm going to take a step back now. When you begin designing a system, you normally want to revisit the principles that you want that system to kind of abide by. So to paraphrase Sam Newman, the definition of microservices, well, what you want is small autonomous services that work together, modeled around a business domain. I kind of wish we had done that in the previous phase. Okay, sometimes you just need to go back to the basics. And we thought, well, let's think about the different business domains again. Do they hold themselves? So going back to that initial slide about the different phases of data ingestion, well, they still actually hold. We're still going to have to download data, not as a batch anymore, because our new provider will give us data every hour. This is a big improvement for us, but we still have to validate it. And we also need to transform it and enrich it and also format it, because the more data we have, in order for the users to be able to query it quite quickly, the data needs to perform for them. And then at the other end, we still have the data warehouse, which holds that kind of most recent data. And if we can pre-calculate some of the kind of fields that the users need, that will also help them. So we looked at our team. We're quite a big team. We're about 30-something people. And we decided to divide our team amongst the squads that would take responsibility of each one of those bounded contexts. So each one of the teams was pretty much going to work on one of the services, sometimes micro, sometimes not so micro, that we're going to deliver. The first one was going to download the data and then think about how can we keep track that we know that we have received the most recent data. The next one was going to be the one holding the validation and thinking how can we decouple that data model that is coming in and what does it make sense to then expose to our users and kind of have that columnar format stored as well. And then the last one was the one about the feedback from our users. So the data aggregations, what are the things that will help our users get most value of the data quicker? So what are these things that we need to pre-calculate? Also this was a great time to think from the very early time that you need to invest in testing. So testing is something that, a bit like security, if you try to bolt it on at the end, you're setting up yourself for failure. It's a lot harder to add it later on. If you start from the beginning, then it just becomes something that is just natural for developers to work on. And this is what the first version of that new pipeline architecture looked like. Very high level. It's quite similar to the previous one. We introduced the notion of the intermediate data lake. And what this was is just a way to decouple that model-driven validation phase and then the data summaries. And it's just a sink for the data, an intermediate sink. So if the data is validated and is formatted, we can just store it there and we know it's in a shape that then we can derive things onwards from it. The part that we received the logs, as I said, that was a lot easier this time. Instead of having to connect to a third-party API, the data was being delivered to us. And we just needed to kind of learn if we were missing anything. But then we had to, as microservice architectures evolve over time, there's also some growth that happens as you learn from them. The first one was, how do we keep track of this data? So the data was being delivered to us in small files. Okay, and it was easier to know those files had some logic behind them. So if we had stored which data had come through and we knew how much we were waiting for, we could kind of automate this bit and see whether we were missing anything as early as possible. So we introduced a Lineage Store, and this is just a relational database. So the different steps would write kind of an event to this relational database and say, this file has arrived, this file has been processed, and that way, all across the pipeline, we would be able to know in which state the data was. If things failed at one of the steps, we would also store an event there. So it became a lot easier for us to triage what had failed and where. We didn't have to kind of debug the entire thing that had been processed. The other part was well, you're storing all this data in another relational database, but then you have to understand how you're storing it, what is the format, and also all your microservices architectures. And if there's people who are new to your team or are less experienced, that's a lot of context overhead that they had to have in their heads to be able to just try out something. So we thought, how do we minimize the knowledge of everyone in the team that they need to understand to be able to kind of deal with this architecture? So someone in the team had an idea, let's develop a command line tool that all the developers can install in their laptops, and we can ask it basic questions. Sometimes the questions are, am I missing any data for the last hour? And it just gives you a report. Okay. Are the service level agreements being broken for the last 30 days? And it just gives you a report. And that is something that has transformed our team. Okay, we have had a number of people joining in the last few months, and they have been okay with doing these things. Whereas in the past, when you ask someone who joined the team, hey, are you ready to get on the on-call rota? People were just like, no, this is just like too much. And now people are just like, well, if I can ask these basic questions, and then with the output that I get, ask for help, then that's okay. So these command line tools work on top of the Lineage Store. Okay. But then we don't want to be running this manually all the time. Okay, this is not productive developer time. So we kind of added some alerts as well on top of this lineage. And one of the main alerts is, when is data missing? We automated this on top of the Lineage Store, and it's just a cron job that checks and queries, is there any data missing for the last hour? And the best part of it is not that, is that it actually automatically will open a ticket with a third party and just tell them, hey, this is the data that I'm missing, and it just tells it all the data that is missing. And it also emails us and says, I've already opened a ticket. You don't need to do anything. So it's been amazing. The next bit, the last part, is about replaying and kind of recovering from failures. Even if architectures are more resilient these days, you're never going to be able to escape failure. You're always going to have to replay data. You're always going to have to recover from it. So we thought we need an easier way to be able to replay data that has failed processing through the architecture. We also added a utility that we will be able to drop the data. So once we knew from that Lineage Store what had failed, we will be able to pump it through at the beginning of the pipeline and just allow it to sit free. And the other really nice thing is, because we don't operate in a batch mode anymore, if anything it fails in any of the steps, what happens is just it's taken out of the processing pipeline. Data will keep flowing, but we will not stop. And it will give us enough time to then figure out what has gone wrong. This is what the new architecture looks like. It's quite daunting. I thought if I show you this from the beginning, you would have been like, oh my God. So things are still the same as earlier, it's just that the boxes are a bit more friendly. I'm now going to go and break down into what were the benefits of using microservices principles in the different parts of the architecture, so then you can kind of tailor the assumptions and the thinking onto how it's working. The first benefit was about enabling the team to be able to choose the technology that was fit for each one of the problems that we needed to solve. I've highlighted in yellow the three kind of main phases of the ingestion, the validation and transformation, and then the summaries. They're very different pieces of technology, and the glue between them is also different. So we have a Java application, which our team had a lot of experience operating and scaling, so it was almost a no-brainer. Then for the validation and enrichment, we chose Apache Spark and its Scala implementation. And this is a bit trickier to operate sometimes because our team doesn't have as much experience, but having it separated from the rest of the pipeline would allow us potentially to even change it if we wanted to. If there are any changes in any of these areas, we can easily deploy them independently. So that's also another big bonus. The benefit number 2, I've already kind of mentioned it, is about the ability to change it and replace it. So the 3 different services, they're deployed independently Okay, there's no dependency between them. So let's say that we look at the data summaries. This is where we chose Apache Airflow. It's another very popular orchestration service in the data space. It's written in Python. Okay, we chose it because, well, our users, data scientists and data analysts, they mostly know Python as a language. So it's kind of like a nice way to collaborate with them. They actually help us build these data summaries. But if something else came along that was more compelling, we could very easily tear it down and then just replace it with the latest language or latest framework that we thought about. The third benefit is about isolating failure. So you want your microservices to be able to fail independently and not for everything to just kind of go down as a result. Okay? So in architecture, we have two ways that we isolate failure. One is in the data that we process. So before, in the batch space, if something failed, everything else failed. So there was no data delivered whatsoever. Our users were very, very unhappy when that happened. Now that data is taken out of the processing stream, and at least they will get some data, and we let them know when the data is complete. Then the other one is about the services. So if the data summaries go down, well, we won't have pre-calculated summaries, but we'll still have data which is not aggregated in the platform for our users. And by it not affecting directly the data warehouse or the upstream service, we can still continue processing. The fourth benefit is about how your microservices architectures, they allow you to adapt and kind of grow as you operate and learn about it. So for us, that meant adding different services that would help us operate it. But we also know that in the future, as the scale of the data that we ingest increases, then it's very likely that perhaps some of the assumptions that we made to build the processing pipeline, we'll have to maybe break them down into smaller problems or just tackle them differently. And that is something that choosing microservices has allowed us to do. Comparing back to what we had earlier, it's quite some growth. Okay, it's been quite a leap in thinking for the team. So, well, what are my main takeaways from this exercise? So the first one of them is, well, change is the only constant. You're always going to have to adapt to change, even if you choose a monolith. As things change and you measure them, you're going to have to adapt. So then make sure that everyone in the team can dive into live issues, because it's a very easy way to spread the knowledge in the team, but also to learn as developers whether the assumptions that we made when we build a new feature, they actually turned to be okay in production. So it's a way to kind of close that feedback loop and learn as we go. And the third one is about being empowered to choose the languages and tools that the whole team owns. Because that way, in some cases of your architecture, where you know the problem really well, perhaps you can take some risks. And in other parts, you just need to go with something that you're very comfortable with, but that then you can operate. This is bringing us kind of towards the end of where we are now, but we're already having conversations about where does the future of our data platform lie? Where are we going with this? So what are the challenges? Well, for me, mainly is how are we going to change this architecture as our data load increases? Also, our user base internally is increasing, and that is a separate challenge, but that's kind of another talk altogether. The next one is about the users' requirements of our data platform. Most of our users use SQL as the interface, but we also have machine learning use cases within the BBC. So we're going to have to enable different access modes and different ways of the users to use the data. The last one is about how can we make it easier for our users. Most of our users, they do not really come from engineering backgrounds. For them, SQL is just an interface, okay, and they only look into the data. So we need to make it to them as easy as possible. But for me, the concern is how do we keep the data secure while making it easier for our users? And to end today, I'm going to tell you something about the data, because we've been talking about pumping data all over, but are we actually getting some insight out of it? And one of my favorite things that we've learned over the last year is about one of my favorite TV shows, which is Killing Eve. And when it was released about a year ago in iPlayer, it was released as the whole series. We all love binge watching these days, okay, because that way we can spend the whole weekend watching something. But what we found out when the data came through was that there was a significant number of users who were watching the last episode before anything else. And we thought there was something wrong in the data. We were like, this can't happen. And I know people, I love reading books, so I know people who actually read the end of a book before they decide whether to kind of read the rest. And we did a little poll around our team, and turns out that there was people in our team who actually watched the last episode before going in. So we thought, okay, this is a new watching pattern. And with this, I will leave you today. Thank you.